back to having fun with chemical formulas. In this activity we're going to be looking at building chemical equations. You will have practiced in activity 10 how to formulate a word equation, and we're going to add to the skills that we learnt there. In order to build a chemical equation, the first thing we need to do is to look at the practical that we're working through, or the scenario that's been given to us in the question, and formulate the word equation. From this, we then need to use the skills that we learnt in activity 4 to 9 to build up what the chemical formula is for each word. Once you've got the chemical formula, you then substitute the chemical formula in for the word, and then put as a subscript underneath the state of each of the formula. It's that simple. The states, as we stated in the last activity, are S for a solid, L for a liquid or water, AQ is aqueous for a solution, and obviously G is a gas. Now there are some things that we need to learn before we go on and look at the chemical formulae. Often you get gases which are given off during reactions. Now some gases will exist as what we call a diatomic molecule. Now this means that these gases in nature form as a pair of atoms. For example, we've got oxygen. As a pair of atoms, it's always written as O2. Hydrogen is always written as H2, chlorine Cl2, and nitrogen N2. We won't be dealing as to why this comes about, we'll learn that later on. But all you need to do is realise that when we've got these gases given off, you must always substitute the formula that we've got below. As well as this, there are other gases that we'll be utilising in this activity. For example, carbon dioxide might be given off. Carbon dioxide always has the formula CO2. Sulfur dioxide, SO2. Now also to help you with this, I've given you some ions tables, cations and anions tables that we used earlier in the activities. I will not be explaining how to do the ions. Go back and look through activities 4 to 9 to refresh your memory if you're unsure. Now the ions that have been included on these tool sheets basically are the ones that we use at St Hilda's. You may have different ones at your school, but these tables will be fine in order for you to complete these activities. I've also put down a note below in MB2 just to explain how you can add a subscript on a Mac. Unfortunately, I'm unable to do this on an iPad, but what a lot of my students have been doing is making a separate text box to put the subscript in and placing it after the symbol. Okay, so let's build a chemical equation. In this example here, we've got the magnesium metal, which has been added with hydrochloric acid in a test tube and resulted in the gas hydrogen being given off and a salt solution of magnesium chloride. This is exactly the same examples we used in the word equation in the last activity. So, what do we do first? Well, first up, what we need to do is to write the word equation. Now the word equation, as you can remember, we must look for the reactants first. That was magnesium and hydrochloric acid. Then we need to look at the products. What were the products in this reaction? Well, we've got hydrogen and magnesium chloride. We then add the states. Remember, magnesium solid, hydrochloric acid as a solution, hydrogen's coming off as a gas, and magnesium as the solution again. So now we need to build the chemical equation. Now, if we've got just straight metal, we'll just add the formula that we would find in the periodic table. We use the metallic symbol. Now the metallic symbol for magnesium is Mg. This is then added to, remember the plus sign, to hydrochloric acid. Now hydrochloric acid is made up of H plus, Cl minus. These two cancel out to make 0, so as a result it's HCl. When these two react, they produce hydrogen gas. Remember back, it's a diatomic molecule, so we write H2, and also magnesium chloride. Magnesium has the ion Mg2+, chlorine has the ion Cl-. So I need 2 chlorines to balance out the magnesium, so I get MgCl2. I then add to them their states. Remember, magnesium is a solid, HCl acid is a solution, hydrogen is a gas, and magnesium chloride again is a solution. That is the chemical equation. It's that simple. Okay, so let's practice this during activity 11. Now, all of the word equations were shown in activity 10. So they're exactly the same, and what I've done is I've tried to make it so that you do the word equation first and then you do the chemical formulae. This is the sort of thing that you might see in a test. You get a reaction, you then have to write the word equation, then you write the chemical equation, and then it finishes off with the balancing equation, which we'll touch on in activity 12. I hope to join you then. Otherwise, good luck, and yes, if you have any problems, replay the video and you should be okay.